Good morning, class. Today we'll be talking to you about growing strawberries with hydroponics and an NFT system versus the drip irrigation. My name is Luke Maddox.
And I'm Katie Callum.
And I'm Angela Hurst.
So today, to look at an overview of what we will be discussing, we'll be looking at the setup and equipment that we used over the course of the semester, the data collection methods, the results that we found, analyzing and discussion, and the conclusions that we've drawn up. So, looking at the NFT system versus the drip irrigation, there's several advantages to both, while also disadvantages. So first, we'll talk about the NFT system. So, looking at the aeration, it equals faster growth in the NFT system. There is minimal growing media and fewer inputs in this system. But the disadvantage is that there is the potential for pump failure, and the root growth could block the channels from having nutritional solution flowing freely down the channel. Now, looking at the drip irrigation, some advantages that you could look at is the high control over the feed and watering, and it's inexpensive compared to other hydroponic systems. And some disadvantages is that there's fewer moving parts and fewer chances to break, and then the irrigation lines could clog. So looking at the experimental design, we looked at two varieties, more notably the Florida Beauty variety and then the Florida Brilliance. For the substrate research, we had 6 substrate boxes for the drip irrigation, and basically the plants were divided half and half, so half of the box would be consistent of Florida Beauty, whereas the other half would be Florida Brilliance. For the NFT, we had 6 benches, and plants were split 1 cultivar per side. And so here is a graphic to look at the how our plants are split up. So on the left side, you have your substrate that had the Florida Beauty. Some had like gravel in it and substrate, whereas others did not have any growing media in it. And on the right side, you had the right side was the drip irrigation. The left side was the NFT system. So now I will turn it over to one of my classmates to talk about the data that we have collected.
Alrighty. So looking at our yield over time, we were able to see that within the NFT system, the gravel treatment in Florida Beauty yielded the most. We can see, it's not shown here, but the Florida Beauty variety grew a lot more in the substrate condition, but it didn't yield substantially different fruit over time. But so there was a lot more vegetative growth, but this didn't necessarily transfer to fruit growth and production. So looking at our chlorophyll and anthocyanin, over time we see some different results. There is one spike in the anthocyanin which could have been due to a reading error, but it seemed to stabilize over time. And then looking at the chlorophyll, we can see a decline in pigmentation after about a month. And this could be related to stress as well as just reduced growth. And just a variety of factors, just with the system not being managed properly or as well as it could be. So looking at the canopy area, we see some interesting results after the first month. After we came back from spring break, the plants did not look as good. They had a lot of pest damage, and this affected the NFT system a lot more severely than it did the substrate. So we see that initially the Florida Beauty is growing more in canopy area than the Brilliance in both in the substrate trial, and then for the NFT they're pretty much the same, but yeah, they tank, and this is most likely as a result of the pest damage in the NFT system. So lastly, looking at pH, That line at the top is the NFT system, and it remains more stable, increasing slightly at the end as our management sort of tapered off there. But then you can see the effects on the substrate are a lot more variable. And so, yeah, and then we look at the EC, we kind of see something similar where there's a lot more variance at the end of the season. And yes, so it steadily increases in some and then it declines in others. So yes, it is quite variable. And lastly, looking at the plant height, we can see another big difference, similar to the canopy area, which is expected after the damage after spring break. There's a huge difference in the height. And we can see that the Florida Beauty performed better than the Florida Brilliance in both Substrate and NFT systems.
Okay, so I'm going to talk a little bit about what we thought we could improve on and a little bit of discussion about the data that we just saw Angela present. So the first thing is monitoring hydroponic systems. When we were conducting our experiment, we probably checked our system 1 to 2 times per week. We would check the yield 1 or 2 times per week, and we would check the pH once a week. And when we found that the pH was a little wonky, we didn't do anything to change it. Part of this is due to the constraints of a class setting, so we have a limited amount of time to work on these per week. But for all of you out there, just know that this is not how you should optimally manage a hydroponic system. As you can see, our pH levels were totally crazy, and our yield wasn't super great. These two things are definitely related. So, if you want to start a hydroponic system in your house, make sure that you check it more frequently than we did.
And use pH up and down, and be on top of your pest problems.
That's right. Don't go on spring break. So, also, you have to be checking constantly for system malfunctions. I personally, one of my theories about why our pH was all over the place in the substrate boxes, whereas the pH was relatively more consistent in the NFT bed, was the fact that we had a couple of instances where our substrate system got either clogged or turned off somehow, and so we came back a couple of times when we were checking on our boxes, and they were totally dry. Drying out your plants is not a recipe for success. So checking frequently for your system to make sure that it's functioning correctly is also really important. Yeah, so that's basically all I have to say about that. Mildew, thrips, and more. Oh my. So, as Angela said, we experienced some pest and disease problems. You can see a little bit of the leaf spot here on the strawberries, but we also had quite a lot of thrips, and quite a lot of aphids, and quite a lot of powdery mildew. Mostly located in the NFT beds, not so much in the substrate boxes. There's no way really to tell what was the cause and what was the effect. It might have been that the NFT beds were more susceptible to pests and diseases because they were more stressed. They didn't like their growing conditions. Or it might be that they were more stressed because of the pest and disease problems. We kind of tend to think that they didn't really like their growing conditions very much because we know that strawberries prefer to be grown in soil rather than other things. But, I mean, technically speaking, we can't really prove it. So, soil analysis. Another really interesting thing, near the end of the semester, we actually had our soil tested, and what we found may surprise you. Not really. We had a lot of excess nitrogen. Not a ton by the standards of this test. It says the optimal range for nitrogen is 40 to 199, and our highest sample was 204. We tested in 2 different places to make sure that they weren't totally different in 2 different boxes. But they were both pretty high, and when you're looking for a plant like strawberries that you're looking for fruit and not so much foliage growth, you don't really want a ton of nitrogen because nitrogen encourages foliage growth, And if the plant's super happy, growing a ton of leaves, it's not going to put its energy into creating berries. So actually, it might be that the reason we saw so much more fruiting in the NFT system, it could have been because of the increased stress. The plants, it might have been that they were thinking, I'm about to die, might as well make some berries before I go, maybe leave some strawberry children behind me after I'm gone. Whereas the ones in the substrate boxes were totally happy, tons of nitrogen, growing lots of foliage. They're not really thinking about anything except themselves.
Like people.
Right. So that's kind of where we're sitting there. Sort of explains a little bit of what we found in our data. So I guess to wrap up, thank you so much for sitting and listening to our presentation. And from all three of us,
Thank you.
thank you.
Thank you.